Hello everyone, welcome to the series of mathematics lessons. This is a continuation of the previous lecture, pair of lines, intersecting lines. Two lines L and M intersect if they have a common point. This common point is generally denoted with O and is called point of intersection because two or more lines are intersecting at one point. Transversal, a line that intersects two or more lines at a distinct points is called transversal. You might have seen road crossing two or more roads or a railway line crossing several other lines. This is an example of transversal. Here we can notice there are two lines L and M and there is a transversal line passing between these two lines at two distinct points, whereas the diagram 5.23 is not an example of transversal. The line P is not a transversal, although it cuts two lines L and M, because the transversal line P is not cutting the lines at distinct points. Instead, it is cutting at a common point. Hence, the line P is not a transversal. As the definition says, a line that intersects two or more lines at distinct points, points is plural, is called a transversal. Angles made by transversal. When a transversal cut two or more lines, they give rise to several properties. Now let us see one by one. There are two lines L and M and P is a transversal line. Now let us see interior angles. 4, 5, 6 are examples of interior angles. 3, 4, 5 and 6. We can think interior angles in simple understanding. Angle 3, 4, 5, 6 lies within the lines L and M, where P cuts at 2 points. We can see the angles 3, 4, 5, 6 are within these two lines. This is also one way of thinking of interior angles. Similarly, for exterior angles, 1, 2, 7, 8 lies outside the lines L and M. This is also one way of thinking about exterior angles. Pairs of corresponding angles. Angle 1 and angle 5 are corresponding angles. They corresponding to each other. Measure of angle 2 and measure of angle 6 is also a corresponding angle. Similarly, angle 3, angle 7, angle 4 and measure of angle 8 are examples of corresponding angles. Pairs of alternate interior angles. 3 and 6 and 5 and 4 are examples of alternate interior angles. Similarly, pairs of alternate exterior angles. Measure of angle 1 and measure of angle 8. Similarly, measure of angle 2 and measure of angle 7. Pairs of interior angles on the same side of the transversal. 3 and 5 are on the same side. 4 and 6 also on the same side of the transversal, and they are interior angles. Transversal of parallel lines. In the previous slide, we studied about transversal in non-parallel lines. Now let us study about transversal of parallel lines. Do you remember what parallel lines are? They are lines on a plane. Now let us consider a plane, an infinite plane which extends in all directions infinitely. The lines that do not meet anywhere are called parallel lines. This is a rough presentation. These are not exactly parallel lines. Just to give you an idea, consider this as a parallel lines. These lines never intersect each other. Traversals on parallel lines give rise to quite interesting results. Now let us see those results. If two parallel lines are cut by a traversal, each pair of corresponding angles are equal in measure. Say for instance, there are two parallel lines and a traversal cut these two lines at two distinct points. The measure of corresponding angles are equal. So for instance, we call it as angle 1 and we will label it as 2. The measure of angle 1 and angle 2 are equal. If two parallel lines are cut by a traversal, a pair of corresponding angles are equal in measure. Similarly, on the other side, the corresponding angles are also equal. Let us call it as 3 and 4. Measure of angle 3 is equal to measure of angle 4. The corresponding angles are equal. If two parallel lines are cut by a traversal, each pair of alternate interior angles are equal. Now let us consider diagram 5.29. These are the L and M are the two parallel lines cut by a traversal T. Now let us concentrate on interior angles. If two parallel lines are cut by a transversal, these are the two parallel lines and these two lines are cut by a transversal, then each pair of alternate interior angles are equal. We need to prove a pair of interior angles are equal if two parallel lines are cut by a traversal. We need to prove measure of angle 1 is equal to measure of angle 6. We are taking just an instance. We can also prove that measure of angle 3 is equal to measure of angle 8. Now let us prove measure of angle 1 is equal to measure of angle 6. We know that when two lines are cut by a traversal, when two parallel lines are cut by a traversal, their corresponding angles are equal. And we also know that vertically opposite angles are equal. Angle 3 is equal to angle 7, angle 6 is equal to angle 2. We know that the measure of angle 3 is equal to measure of angle 7 because they are vertically opposite angles. And we also know that when two lines are cut by a traversal, their adjacent angles are equal. So angle 7 is equal to angle 8. And also measure of angle 3 is equal to measure of angle 7. So indirectly we can say that measure of angle 8 is equal to measure of angle 3. Here we can notice the measure of angle 3 is equal to measure of angle 7 and measure of angle 7 is equal to measure of angle 8. These two are equal. If these two are equal, measure of angle 3 is equal to measure of angle 8. Measure of angle 3 is equal to measure of angle 8. If two parallel lines are cut by a traversal, each pair of alternate angles are equal. 3 and 8 are alternate angles. They are equal. Similarly, we can prove it for 1 and 6. Even 1 and 6 are interior angles. If the two parallel lines are cut by a traversal, then each pair of interior angles on the same side of the transversal are supplementary. Supplementary means when you add two angles, the resulting sum should be 180 degree or a straight line. Both are same. Now let us prove this statement. These are the two parallel lines. If two parallel lines are cut by a traversal, then each pair of interior angles on the same side of the traversal are supplementary. 1, 3, 6, 8 are interior angles. Sum of measure of angle 3 plus sum of measure of angle 6 should be equal to 180 degree. Similarly, sum of measure of angle 1 and measure of angle 8 must be equal to 180 degree. Now let us prove this. We know that the measure of angle 1 plus measure of angle 2 is equal to 180 degree because 1 and 3 form a linear pair. But measure of angle 1 is equal to measure of angle 6. We saw this when we are proving this statement. If two parallel lines are cut by a traversal, each pair of alternate interior angles are equal. This angle must be equal to this angle. Therefore, we can say that measure of angle 3 plus measure of angle 6 must be equal to 180 degree. So what we are doing is we are replacing measure of angle 1 with measure of angle 6 because both are equal. So measure of angle 3 plus measure of angle 1 should be equal to 180 degree. We can rewrite this statement as this. If two parallel lines are cut by traversal, then each pair of interior angles on the same side of the traversal are supplementary. These interior angles are on same side of the traversal. When we add these two, we will get supplementary. Sum of these two angles will be equal to 180 degrees. Similarly for measure of angle 1 and measure of angle 8. Now let us see how do we check whether the lines are parallel or not. If two lines are parallel, then we know that traversal gave rise to pairs of equal corresponding angles, equal alternate interior angles, and interior angles on the same side of the traversal being supplementary. We saw this in the previous slides. We proved all three conditions. When two lines are given, is there any method to check if they are parallel or not? We are just conversing the statement. When a traversal cuts two lines, pairs of corresponding angles are equal, then lines have to be parallel. When a traversal cut two lines, traversal is cutting two lines L and M such that pairs of corresponding angles are equal. If their corresponding angles are equal, then the lines L and M are said to be parallel. When a traversal cuts two lines, here are the two lines, such that here are the two lines, a traversal cutting at two distinct points, such that pairs of alternate interior angles are equal. If these angles, if pair of interior